Hello everyone, my name is Diego Medrano, and in this video I'm presenting my individual project on unit testing. Specifically, I'm focusing on unit testing in Java using JUnit 5, and I'll also explain mock objects and Mockito. I'll explain the concepts with clear definitions, diagrams, and simple real-world examples so you can understand how unit testing works and why it matters. By the end, you should be able to explain what unit testing is, how JUnit fits into it, and what assertions and exceptions tests do, what an A-trip means, and when and why we would use mock objects. Some discussion points. Here's the roadmap for the presentation. First, I'll introduce unit testing and how it fits into the bigger picture of software testing. Then, I'll explain JUnit 5 and what assertions are, since assertions are how tests actually check correctness. After that, I'll cover the principles of good testing using the acronym A-TRIP, which is a good checklist for test quality. Then, I'll explain mock objects and Mockito, and finally, I'll talk about what it means to write testable code, because design choices make unit testing either easy or really painful. So some software testing overview. Before zooming into unit testing, I want to place it inside the overall software testing picture. There are multiple levels of testing. The most common set is unit testing, integration testing, system testing, and acceptance testing. Unit testing is at the smallest level. You test one unit of behavior, like a single method or class, with controlled inputs and accepted outputs. Integration testing is when you test that multiple components work together. For example, your service class plus a real database connection, or your API layer plus the data layer. System testing is when you test the entire application as one system, basically end-to-end behavior, often in an environment that looks like production. Acceptance testing is when you test from the perspective of the user or business requirements. It answers, does the system meet the requirement? On the left, the blocks show a simplified idea of the testing pyramid. In many projects, you aim for lots of unit tests because they're fast, then fewer integration tests, and then fewer full system or acceptance tests because those are slower and most expensive to run. Unit tests are pretty quick, but fewer integration tests, the more you go down, it takes longer and longer and more expensive to run. So the main idea is unit tests give feedback, and the higher level tests give confidence that everything works together. So what is unit testing? A unit test is an automated check that verifies a small piece of code behaves the way we expect. When I say small piece, I mean a unit, like a method, a function, or a small class behavior. A unit test follows a simple concept. Given an output, we expect a specific output or behavior. Given an input. Given an input, we expect a specific output or behavior. The reason unit tests are valuable is because they are fast and repeatable. You can run hundreds of unit tests in seconds. Unit tests also encourage better code design because code that is hard to test is often overly complex or tightly coupled. Another key point is isolation. In a unit test, we avoid real databases, real networks, and real external APIs. If we test with those, that's usually an integration test. So, if I'm testing a method that calculates tax, I shouldn't need a database at all, just the input values and the expected result. Now, let's talk about JUnit 5. JUnit is the most common unit testing framework for Java. It gives you a standard way to write tests and test runner to execute them. JUnit 5 is the modern version. It has a newer programming model called Jupyter, and it runs on a platform that can discover and execute tests. Conceptually, you can think of JUnit as giving you two main things. First, the structure, ways to mark methods as tests and organize test executions. Second, the checks, a big set of assertions that let you verify expected behavior. JUnit 5 also supports modern patterns like parameterized tests, nested tests, and tags to organize tests. But the most important thing for this presentation is understanding what JUnit does at a high level. It makes unit testing consistent and automated in Java. So how unit tests are structured. AAA. A very common way to structure unit tests is the AAA pattern. Arrange, act, assert. Arrange means you set up everything you need for the test, your objects, inputs, and any test data. Act means you call the method you're testing. This is the single action that produces the behavior you want to verify. Assert means you check the result. You compare what actually happened to what you expected to happen. This structure is useful because it keeps tests readable. When someone reads your test, they can quickly see what was set up, what happened, and what was checked. Here's a simple verbal example. Suppose we're testing a method that adds two numbers. Arrange creates the calculator object and chooses inputs like 2 and 3. Act calls add 2 and 3, and assert confirms the result is 5. Even without code, the idea is very clear. Assertions. Assertions are the core of unit tests, because assertions decide if a test passes or fails. An assertion is basically a statement that says, I expect something to be true. If that expectation is not true, the test fails and the test framework reports the failure. Common assertion styles include checking quality, checking a condition, and checking that something is not null. For example, assert equals would compare an expected value and an actual value. A plain English version would be, I expected the total price to be $10.80, but the program gave me $10.50. This test would fail. Another example of assert true, which checks a condition, is true. For example, I expected that when a user enters a valid password, the system says true for is valid password. Good assertion should be specific. The more specific the assertion, the easier it is to understand what went wrong. So, assertions don't just catch bugs, they also communicate what the correct behavior is supposed to be. Testing exceptions. Not all correct behavior is a normal return value. Sometimes the correct behavior is to throw an exception. An exception test verifies that the invalid input trigger the correct error response. In JUnit 5, the main concept is you run the code and you expect an exception of a specific type. A simple example is dividing by zero. In many systems, dividing by zero should throw an error instead of returning a random number. So, a unit test would say, when I divide by zero, I expect an illegal argument exception. Another example could be a method that requires a non-empty username. If the username is empty, the correct behavior might be to throw an exception explaining that the username is required. Testing exceptions is important because it documents the contract of the method. It makes it clear what inputs are allowed and what happens when inputs are not allowed. So what unit tests do and do not do. This slide is basically all about exceptions. Unit tests are great for verifying small pieces of logic quickly, and they help you refactor with confidence. However, unit tests don't automatically guarantee the entire system works end to end. For example, a unit test might confirm that a method builds a SQL query correctly, but it does not prove the database connection works or that the query returns correct real data. That would be an integration test. Also, unit tests only test what you choose to test. So, if you never test a boundary condition, you can still have a bug at that boundary. The right mindset is unit tests are a fast safety net, but they're part of a bigger testing strategy. Alright, now let's talk about the A-trip principles. This is a great checklist for writing high quality tests. A stands for automatic. Tests should run automatically, and the pass or fail result should be automatic. You shouldn't have to print something and manually check it. T stands for thorough. Thorough tests cover happy paths, edge cases, boundaries, and failure scenarios. A happy path is the normal expected use case. An edge case is something unusual, like an empty string or a maximum value. R stands for repeatable. A test should produce the same result every time you run it. If a test sometimes passes and sometimes fails without code changes, that's a flaky test, and it destroys trust in the test suite. I stands for independent. Tests shouldn't depend on each other's order to shared state. If test B only passes if test A ran first, then your tests are not independent, and the suite becomes hard to maintain. A lot of instructors also mention readability and professionalism. In other words, treat test code with the same respect as production code, because you will maintain tests for a long time. Testability. Testability is about how easy it is to write reliable tests for your code. The first idea here is deterministic behavior. Deterministic means given the same input, you always get the same output. For example, a method that uses the current time inside it might not be deterministic unless you control the time in the test. The second idea is dependency injection. Dependency injection means the code gets its dependencies from the outside instead of creating them internally. This matters because if your code creates its own database connection internally, it's hard to replace that database with a testable code. But if the dependency is injected, you can swap it with a mock or stub in unit tests. The third idea is avoiding side effects. A side effect is when a method changes something outside of what you're trying to test, like writing to a real file, updating a real database, or calling a real API. Side effects make tests slower and harder to repeat, so we typically isolate or replace side effects in unit tests. Writing testable code. Now we're going to connect testability to actual code design. Testable code is usually simple, decoupled, and focused. One principle is small methods with one responsibility. If a method does 10 different things, it will require complicated tests and it will break easily. Another principle is to prefer pure functions when possible. A pure function is a function where the output only depends on the inputs and it doesn't change external state. Those are very, very easy to test. Another important principle is to avoid creating dependencies inside of methods. Instead of doing new database connection inside your service method, you inject the database interface from the outside. And finally, using interfaces for external services is key. If you have a payment gateway interface, then your unit test can replace it with a mock and control what happens. Test doubles. This slide introduces a family of concepts called test doubles. A test double is a stand-in object that replaces a real dependency during tests. There are several types, and the names can be confusing, so I'll define them clearly. A dummy is an object that is passed around but never actually used. It exists just to clarify a parameter. A stub is an object that returns predefined data. For example, a stub repository might always return the same user record. A fake is a simpler working version of something real. A common example is an in-memory database used instead of a real database server. A spy records information about how it was used, so you can check calls after the fact. And a mock is specifically used to verify interactions. So a mock is not just returning data, it's also checking whether methods were called, how many times they were called, and with what arguments. This is where Mockito becomes useful, because Mockito helps create mocks easily. Let's focus on mock objects specifically. A mock object stimulates a real dependency, like a database, email service, or API. The purpose is to isolate the unit under test. If I'm testing checkout service, I do not want the test to actually call a real payment provider. A real payment provider would be slow, could fail due to network issues, and could even charge real money if configured incorrectly. So, in a unit test, we replace the payment provider dependency with a mock object. Then, we can control what the dependency returns, and we can verify that our unit interacted with it correctly. This keeps unit tests fast, repeatable, and independent. Mockito is a popular Java framework that helps you work with mock objects in a unit test. Conceptually, a Mockito supports two big actions, stubbing and verifying. Stubbing is when you tell the mock what to return. For example, you can say, when the payment gateway is asked to charge $20, return true. Verifying is when you confirm that something happened. For example, you verify that charge was called once with the correct user ID and amount. The diagram shows the idea. Checkout service depends on payment gateway. In production, payment gateway might call a real external API. In unit testing, we replace payment gateway with a mock, so the real API is not called. Then, we test checkout services behavior in a controlled way. A good real-world example is, what should happen if the gateway returns false, meaning the payment failed? Your unit test can stimulate that return value and confirm with checkout service responds correctly, maybe by returning an error message or not creating an order. So now I want to talk about some common mistakes people make when they're writing tests. One is overmocking. If you mock everything, your tests become tied to implementation details and they break when you refactor even if the behavior stays correct. Another pitfall is flaky tests. Flaky tests are tests that sometimes fail and sometimes they pass. This often happens because of time-based logic, random values, or shared state between tests. Another mistake is testing the wrong thing, like verifying private eternal steps because of the public behavior the user cares about. The last pitfall is giant tests that are hard to read. If a test is hard to understand, it will be hard to maintain, and people will ignore it. So the goal is clear, readable tests that focuses on behavior. So finally, this slide summarizes the types of resources used for this project. I use video resources for high-level explanations and best practices. I use some web articles and blogs, including Martin Fowler, to understand testing vocabulary like test doubles and how unit tests fit into software design. I use technical documentation from JUnit 5 and Mockito to make sure the definitions match the real frameworks. And I reference Wikipedia topics like software testing, unit testing, and mob objects for baseline definitions and terminology. And that's basically it. Here are some key takeaways. Unit tests verify small behaviors quickly and automatically, and they help you catch issues early. JUnit 5 provides the structure and assertions for writing unit tests in Java. ATrip is a great checklist to keep tests automatic, thorough, repeatable, and independent. Mock objects and Mockito help isolate your unit from external dependencies so tests stay fast and reliable. And finally, writing testable code comes down to deterministic behavior, dependency injection, and avoiding side effects. Thanks for watching.